Hi everyone, this is your math guru. In this video, I'm going to show you how to solve the following question on the nature of roots. Starting with the first part of the question, I have for which values of p will the equation x open bracket 4x plus 3 close bracket equals negative p have a real root and b non-real root. Starting with the real roots, I'll start by writing my equation, which is x in bracket 4x plus 3 equals negative p. The first step is to rewrite my equation in the standard form, which is ax squared plus bx plus c equals to 0. So what that means is I'm going to expand the bracket for x squared plus 3x equals to negative p, and then move my negative p to the left hand side. I have 4x squared plus 3x plus p equals to 0. After writing in the standard form, I can easily pick the coefficient of x squared, which would be the value of a, that's 4. B is the coefficient of x, which is 3, and my c is my constant term, p. For me to have real roots, I need my delta to be greater or equal to 0. That's for real roots. And the formula for finding delta, that's b squared minus 4ac must be greater or equal to 0. So slotting in the values, b squared, that's 3 squared minus 4 times a is 4 times c, that's p, must be greater or equal to 0. I'm going to move to my right hand side. I have 3 squared, that's 9, minus 16p must be greater or equal to 0. Moving my 9 to the right hand side, I'm left with minus 16p must be greater or equal to negative 9. To find p, I'm going to divide both sides by negative 16. Whatever you do on your left, you do on your right. Negative 16 divided by negative 16, that's 1. Therefore, p, note that when you're dividing your variable, the coefficient of a variable, by a negative number, then your inequality sign is going to change. You're going to write exact opposite. So because initially I have greater or equal to, that's going to change to less or equal to 9 over 16. So for that equation to have real roots, I need the value of p to be less or equal to 9 over 16. Let's go to the second part of the question that says for which values of p will the equation have non-real roots. I'm going to leave the rewriting of the equation in the standard form as it is because I'm using the same equation. But what I'm going to change is for me to have non-real roots as stated, then I need my delta to be less than 0. And what that means is my b squared minus 4ac must be less than 0. Slotting in my values again, 3 squared minus 4 times a is 4, c is p, must be less than 0, so I have 9 minus 16p must be less than 0. Going to continue on the right hand side. I have 9 minus 16p less than 0. Moving my 9 to the right hand side, I have negative 16p must be less than negative 9. And to find p, I divide again by negative 16. And because I'm dividing by negative value, the coefficient of p, my inequality sign is going to swap. So it's not going to be less than, it's now going to be greater than 9 over 16. So for me to have non-real roots, the value of p must be greater than 9 over 16. Please don't forget to click on the like and subscribe button below for more easy to understand math concepts. In the second example, I have for which values of k will the equation x squared plus 2kx plus 4x plus 9k equals to 0 have equal root. I'm going to write the equation out. X squared plus 2kx plus 4x plus 9k equals to 0. In order to find the value of a, b, and c, I'm going to rewrite my equation. X squared plus, I factor out x, I'm left with 2k plus 4 plus 9k equals 0. This way, I'm able to find the coefficient of x squared, which is the value of a, that's 1. Coefficient of x, which is the value of b, will now be my 2k. It's an expression. So I put that in a bracket, 2k plus 4. And my constant term will be 9k. So the question says, for which value of k will the equation have equal root? For me to have equal root, then I need my delta to be equal to 0. This works for equal root. Therefore, substituting for delta, that's b squared minus 4ac equals to 0. My b, that's an expression. I'll leave that in a bracket, 2k plus 4, all squared minus 4 times a is 1, c is 9k, close bracket, must be equal to 0. Expanding, I have 4k squared plus 8k plus 16. Before I find my 16, I have another 8k plus 8k plus 16 minus 4 times 9, that is 6k, equal to 0. Collecting like terms, I have that as 4k squared minus 20k plus 16 equals to 0. I'm going to look for a common factor, which is 4. So I have 4 in bracket, k squared minus 5k plus 4, close bracket, equal to 0. Then, to solve for k, I'm going to factorize k squared minus 5k plus 4. The 4 can fall off. I have k multiplying k, then I have negative 4, negative 1. So therefore, equating the two brackets to 0, I have k minus 4 equals to 0, or k minus 1 equals to 0. So the value of k that will make that equation have equal roots will be k equals to 4, or k equals positive 1. Thanks for watching. Bye.